Okay, so this is recording now. Okay, so we're solving equations with x as an index this time. We're looking at the types of questions that are in question 7. So, for example, we have 3 to the power of 2x plus 3 to the power of x is equal to 90. So in this case, we have, it'll work out as a quadratic expression. So these are slightly different and there is a set technique for them. So is everybody ready? So take out your pen, you're going to be writing these down with me. Okay, all set? All right, let's get going. So we have 3 to the power of 2x plus 3 to the power of x is equal to 90. So you are solving these as a quadratic equation. The first thing you need to do is bring all of your terms to one side of your equation first. So bring all of your terms to one side of the equation first. So this will give me 3 to the power of 2x plus 3 to the power of x minus 90. These are different than the questions you were doing over the past 2 days because you cannot simplify your exponents here. Like you have no rule. If you have your log tables open on page 20, you have no rule for when you're adding together values that have the same base but different exponents. You can't add those together. So instead, we call y 3 to the power of x. So take your middle term here. Whatever that middle term is, 3 to the power of x, call it y. So y is equal to 3 to the power of x. And then we're going to try and substitute in, wherever we see 3 to the power of x, we're going to write y instead. Now there's a problem. We can substitute it in here, 3 to the power of x, but we cannot substitute it in for 3 to the power of 2x. We can't substitute that in. So what we do is we use our indices rules to write out each term as 3 to the power of x. So we're going to use our indices rules to pull apart our terms so that we can substitute in 3 to the power of x for y. Alright, so what rules do we have? We know that a to the power of p times q is the same as a to the power of p all to the power of q. So when you have two values multiplied together, if you have two exponents multiplied together as we do here, it is the same as writing a to the power of your exponent all to the power of your second exponent. So 3 to the power of 2x can be written as 3 to the power of x all squared plus 3 to the power of x minus 90 equals 0. From here, wherever you see 3 to the power of x, substitute in for y. We're left with y squared plus y minus 90 equals 0. You will be left with that quadratic equation here. So that's what you're trying to get. You're trying to make a simple quadratic equation that you can solve. So we have y squared plus y minus 90. We are now going to solve for y. So to solve for y, we're going to factorize our equation. So we want the factors of 90 that times to make, or that add to make your value of 1. So what are our factors of minus 90? Well, they are 10 times minus 9 gives us minus 90. 10 minus 9 gives us our middle value of 1. So our factors are 10 and minus 9. Factorizing our equation, we have y plus 10 times y minus 9 equals 0. From here, solve for y. So take both of your brackets and put them equal to 0. That gives us y plus 10 equals 0 and y minus 9 equals 0. From here, solve for y. So y is equal to minus 10 and y is equal to 9. However, your value of y is equal to 3 to the power of x. Any value powered. Okay, so it doesn't matter any term at all. Any exponent will never be a negative number. Okay, so 3 to the power of any exponent at all. It will never ever be negative. So y cannot be negative. Therefore, y cannot be minus 10. So therefore, y is equal to 9. Now that we find our value of y, you need to substitute in to solve for your value of x. We know that y is equal to 3 to the power of x. So if y is equal to 3 to the power of x, substituting in for y, we get 9 is equal to 3 to the power of x. We now want to solve for x. To solve for x, we go back to the steps that we were looking at yesterday and the day before. To solve for x, we need to write both terms with a common base. So 9 is the same as 3 squared. We then equate our exponents. So 2 is equal to x. Okay, and all of these questions are the same. So what you're going to do is write them as a quadratic equation and solve for it. Okay, let's try another one. I think I said we worked to do from question 5, but sorry guys, it shouldn't have been question 5. The questions that we're doing today, I lied to you guys accidentally. It's question 8, not question 5. You probably were wondering what I was doing there. So the questions we're doing today are question 8. So we're doing question 8 and exercise 7.2. I'm so sorry guys, question 8. Okay, so we are working through the questions on question 8, not question 5. I don't know why I wrote question 5 by mistake. Okay, so is everybody all right with that? We're going to do question 8. I'm going to continue with them. If you feel confident to do them by yourself, you are doing question 8 now. If not, then you're doing them with me. Stay on and do them with me. Is everybody ready for the next one? Okay, is everybody clear? It's question 8 we're doing, not question 5. You probably thought you were getting that very lightly. So it's question 8. All right, can I move on? Are we ready for the next one? Okay, can you let me know when you're ready? Great. Thank you. Thanks, Molly. Thanks, Leo. Okay, so I'm going to continue with question 8. If you think you're faster than me, you work away with it. We have, this is question 8, part 6. Okay, so I'm going to do question 8, part 6. 2 to the power of 2x minus 6 to the power of 2x plus 8 is equal to 0. You want to solve for x. So your hint is when you have this 2 to the power of x or 3 to the power of x in your equation twice, and if there's an adding and a subtraction sign between them instead. So if you have 3 terms, 1, 2, 3 terms, we're using this technique. So the first thing you do, make sure all of your terms are on one side of the equation. Ours are, so that's fine. Then let your middle term equal y. So that's y is equal to 2 to the power of x. So I want to substitute in y everywhere I see 2 to the power of x. You're trying to make a quadratic equation. Equation. To do that, you have to use your indices rules to write each term with a 2 to the power of x in it, so that you can take out the 2 to the power of x and pop in your y. So how can we use our rules? We know that a to the power of p times q is the same as a to the power of p all to the power of q. So you can have different rules here. We're going to look at a few different ones. You should have page 21 open at all times in this chapter. So that means that 2 to the power of 2x is the same as 2x squared minus 6 times 2 to the x plus 8 equals 0. And now we can just pop in y everywhere we see 2 to the power of x. This gives me y squared minus 6y plus 8 equals 0. We have a quadratic expression. Once we have our quadratic expression, we can solve by factorizing our quadratic. So factorizing this, we want to find the factors of 8 that add to make minus 6. So that'll be minus 4 and minus 2. So minus 4 times minus 2 gives me plus 8. Minus 4 minus 2 gives me minus 6. So we want factors times to make your end value and the factors that add to make your middle. So my factors are y minus 4 and y minus 2. From here we want to solve for y. So we put both brackets equal to 0 and we find our values of y. Y is equal to 4 and y is equal to 2. Now, don't forget what you're trying to do here. You are trying to solve for x. So, sorry guys, this shows from the last question. So from here, to solve for x, we know that y is equal to 2 to the power of x. So substitute in your values for y and solve for x. 4 is equal to 2 to the power of x. To solve for x, I need to write my term with a common base. 4 is the same as writing 2 squared. So 2 squared is equal to 2 to the power of x. And to solve for x, equate your indices. Now we're not done yet. X can be equal to 2, but we will also get the same answer when y is equal to 2. So we must substitute in 2 for y and solve for x again. That means 2 is equal to 2 to the power of x. When you have no exponent, when you have no exponent, it's the same as writing 2 to the power of 1. That means that x is equal to 1 and x is equal to 2. Okay. We try one more. Any questions so far? Okay, let's try our next one. Let me know when you're ready. Thanks, Philomena. All right. Okay, this one looks a bit trickier, but it's the same idea. Solve our equation 3 to the power of 2x plus 1 minus 28 times 3 to the power of x plus 9 equals 0. So we're going to have to do the exact same thing. We want to first make sure that everything is on one side of the equation. Then I want you to let y equals 3 to the power of x. So we want to write everything here in terms of y. So we're going to say y is equal to 3 to the power of x. Now, you're going to use your indices rules to write each term with 3 to the power of x in it. So here, we need to separate this term using our indices rules to write it in terms of 3 to the power of x. This time we have a plus sign. So we know our first rule, a to the power of p plus q is the same as writing a to the power, actually I'll write it over here at the other side. A to the power of p plus q is the same as writing a to the power of p times a to the power of q. When you're adding exponents together, it is the same as multiplying values that have the same base. This means that this term can be written as 3 to the power of 2x times 3 to the power of 1, all minus 28 to the power of 3x plus 9 equals 0. Keep using your indices rules to separate out that first term so it is written in terms of 3 to the power of x. So we now know that a to the power of p times q is the same as a to the power of p all to the power of q. So this gives me 3 times 3 to the power of x squared. So I'm just bringing that 3 in front. So 3 times, that's a times sign there, 3 times 3 to the power of x squared minus 28 times 3 to the power of x plus 9. So now we can substitute in y for 3 to the power of x. We now have 3y squared minus 28y plus 9 equals 0. We have a quadratic equation, so we need to solve for our quadratic equation. To solve for your quadratic equation, you factorize. factorizing, we mean that we times our n terms together. So what are the factors that times to make your n terms and add to make your middle terms? Okay, so that's minus 27 minus 1y gives us minus 28y. From here, we solve for y. So 3y is equal to 1. So y is equal to 1 over 3. And y is equal to 9. Once we find our values for y, we substitute them into our equation for y to solve for x. That gives us 1/3 equals 3 to the power of x. We want to solve for x. So I don't know what to do with our exponent here. So I'm going to bring that to our top. We know that 1 over a to the power of p is the same as writing a to the power of minus p. We now have the same base, so we can equate our exponents. Minus 1 is equal to x. And 9 is equal to 3 to the power of x, which means 3 squared equals 3 to the power of x, and x is equal to 2. Okay guys, you're going to do question 9. I'm doing most of them with you. I've done question 1, I've done question slightly different, but you can take this as question 4 done, question 8 part 4, and I have done question 8 part 6 as well. So I'm going to do one more with you of these type. I know these are trickier. Note, we will be doing these again on Monday, so you will have another day practicing these. So try to just do them with me right now. And you will be doing them again on Monday. Remember, your test tomorrow is chapter 4, length, area, and volume. Okay. So we have done question 8 part 1, question 8 part 4, and question 8 part 6. So this isn't exactly 8 part 4, but it's very similar to it. All right, you ready to try another? Let me know. So the hardest part of this is always when you have this weird term here, you are trying to separate, you're doing the opposite of what you were doing yesterday. Yesterday you were simplifying your exponent, you're adding them all together. Here you're pulling apart that exponent, so you can substitute in your term 3 to the power of x. Okay guys, let me know when we're ready to try one more. And again, if you're confident with them, you're doing question 8, feel free to do them on your own. Great, thanks Andrea. This all nice and tidy. See, nice and tidy for you guys. Okay. Okay, I'm going to do one more of these. We're going to do question 8, part 3. So, question 8, part 3. Are we ready? Okay, so I've had one person tell me they're ready, so I'm going to assume you guys are the same, unless you tell me otherwise. This is coming off the board. Okay, so we're looking at question 8. part 3. 2 to the power of 2x plus 1 minus 15 to the power times 2 to the power of x minus 8. And guys, these type of quadratics, they're much more common than the questions that you were doing yesterday, like question 6. The quadratics seem to be where they tend towards more. So when focusing your revision, I would focus on making sure you can do question 8. We'll be doing question 9 and 10 on Monday, but for now, these type of questions do come up regularly, more than the long exponent solving ones of question 5 and question 6. Alright, so we're setting up in the same way. Make sure all of your terms are on one side of the equation, which they are. Then you have something, you have 1, 2, 3. You've got 3 terms. So if you have 3 terms, call your middle term y. So y is equal to 2 to the power of x. Then use your indices rules to write each term in the form of something times 2 to the power of x. So we have 2 to the power of 2x plus 1 minus 15 to the power of times 2 to the power of x minus 8 is equal to 0. The first term is the one that looks weird. You have to use your exponent rules to pull it apart. So our rules state that a to the power of p plus q is equal to a to the power of p times a to the power of q. So if there's an addition sign between your exponents, you can separate that out by multiplying 2 values together that have the same base. So this is the same as saying 2 to the power of 2x times 2 to the power of 1 minus 15, 2 to the power of x minus 8. Remember what you're trying to get. You're trying to get a 2 to the power of x, so we're closer, but we're still not there. A to the power of p times q is the same as a to the power of p all to the power of q. So now we can write this as 2 to the power of x all squared times 2, and then the rest of your equation. Alright, so let's tidy this up. This gives me 2y squared, so I'm just writing that 2 in front instead, minus 15y minus 8 equals 0. You will have some sort of quadratic expression. And now we solve for a quadratic by factorizing. What are the factors of your n values that add to make your middle value? Okay, so you find your factors, and now solve for y. So we have 2y equals minus 1. So y is equal to minus 1 over 2. And y is equal to 8. So y cannot be a negative number. See, y is 2 to the power of something. You cannot make a negative number here. So it doesn't matter what your exponent is there, you will never get a negative number. So y cannot be minus 2, minus 1 over 2. So we now need to solve for x. So if y is equal to 2 to the power of x, 8 is equal to 2 to the power of x. We want to solve for x. To do this, you must write both terms with a common base. So 8 is the same as 2 to the power of 3. Once your bases are the same, you can equate your exponents to solve. Alright guys, so I've done question 8, part 1, 3, 4, and 6. You have 2 of them left to do. You've got part 2 and part 5 to do. You can try part 4 as well. Part 4, I did one similar but with slightly different values. So if you have any questions, feel free to stay on and ask me about these. Otherwise, take these examples, use the examples to do them out. You will be doing them again on Monday, you'll be happy to hear. So don't forget, you have your test tomorrow. Okay guys, thanks so much. Well done. Thanks guys, well done. And I will put this recording up for you guys.